Hi, this is Dr. Subhatra. In today's session, I am going to discuss about one of the mineral admixture, that is a silica fume. Silica fume is also referred to as a microsilica or condensed silica fume. Is another material that is used as an artificial pozzolanic admixture. It is a product resulting from the reduction of high purity quartz with coal in an electric arc furnace in the manufacture of silicon or ferrosilicon alloy. Silica fume rises as an oxidized vapor. It cools, condenses and is collected in cloth bag. It is further processed to remove the impurities and to control the particle size. Condensed silica fume is essentially silicon dioxide in a non-crystalline form. Since it is airborne material like fly ash, it is spherical in shape. It is extremely fine with a particle size less than 1 micron with an average diameter of about 0.1 micron and about 100 times smaller than the average cement particles. Silica fume have the specific surface area of about 20,000 meters square per kg. So the silica fume is available in the following states. One is in powder form. This one is the powder form. Next is the densified forms. The size of the particle is bigger. Then the third one is in the slurry form. When it is available in powder form, it is very difficult to handle because of its low specific gravity. It is sticky and self-agglomerating with a tendency to create small weak lumps. Its low density yields small loads to bulk tankers. So therefore, since it is very difficult to handle, we will be using it in a bagged product. Then coming to the densified silica fume. Densification is performed by means of aerating and tumbling the silica fume powder with a compressed air. Unlike the powder, the densified version is very easy to handle and transport and flows well pneumatically. But an efficient superplasticizer is required for this densified silica fume to deflocculate, and that will act as a good dispenser of the silica fume. Coming to the slurry, it's a liquid form. 50% water, 47% silica fume and 3% chemical agent will be there. That keeps the particle in suspension and prevents gelling. The slurry form is susceptible to gelling in cold climates. So it is very efficient way of dispensing. And the storage space required will also be very less since it is in the liquid form. Coming to the properties of silica fume, its specific gravity is 2.2 and the fineness is 20,000 meters square per kg and the bulk density as produced is 130 to 430 kg per meter cube. If it is in slurry form, it is greater, the density is greater, and in the densified form, it is lesser than the slurry form. When it is in powder form, it will be very lesser compared to the densified form. And coming to the color, it is in the color of light gray to dark gray, as like the cement color. Almost 10 times it is costlier as much as PC, Portland cement, typically used in the replacement level of 5 to 15%. Benefits from the silica fume is mainly due to the pozzolanic reaction, which produces an additional calcium silicate hydrate gel, as well as due to the particle packing of the fine silica fume particles. Now, let us see what are the effects of the silica fume on fresh concrete and hardened concrete. The fresh concrete, due to its high fineness, it increases the water demand of the concrete. It is very sticky and cohesive. It is less prone to the slump loss. Because of its cohesiveness, higher slump is needed in place of silica fume concrete. Bleeding has been reduced. In dry places where the evaporation rate is more, in that case, plastic shrinkage may occur. It is not compulsory that it will come. It may occur. Then coming to the hardened concrete properties, compressive and flexural strength will get increased. But the chloride permeability and diffusion will get reduced. All these are comparing to the normal ordinary Portland cement. The elastic modulus will get increased and the concrete becomes stiffer when silica fume is used inside that. The creep and shrinkage will get reduced only when the replacement level is greater than 15%. If it is below that 15%, it won't have any problem in creep and shrinkage. Due to the higher stiffness, its resistance to creep and shrinkage deformation will be higher. The amount of air entrainment required for a particular volume of air is increased. Freezing thawing will also get reduced. So there are many advantages in using this silica fume. Thus, silica fume shows a better resistance to chemical attack. Therefore, the corrosion rate is reduced on a large scale. This is because of two reasons. The lower permeability of the silica fume concrete causes a lower availability of moisture and oxygen. When the moisture and oxygen content entering inside the concrete is lower, there itself the corrosion rate will be lower. And another reason is due to the high resistivity of silica fume concrete makes the flow of electron difficult. So when it does not pass the current to pass through it and it is highly resistant, corrosion will get reduced. So these are the two reasons why the silica fume concrete is highly resistant to corrosion. So the silica fume concrete has a major advantages, and hence it can be used in the practice. Thank you.